Okay, so what we're going to look at today is Euler's method, which his name looks like it's spelled Euler's. It's pronounced Euler's method. So what this, and just as a heads up, this is another one of those very tedious but not necessarily difficult things, but it's going to get, the numbers get messy. You'll see. All right, this is used to approximate a particular solution of a differential equation. I guess at a value, at a specific value. All the differential equations I have given you and will give you are what's called separable. In other words, you're able to get all of the y values on one side and all of the x values on the other. Do you see what I'm saying? Like you're able to do the problem. I'm not going to give you an undoable problem. But let's say you can't separate it. This allows you to approximate the answer to a particular solution at a value without actually having that equation. You're nodding your head. Does that make sense? Like it allows you to make that approximation without actually solving the differential equation. All right, so you are going to start at what's called x0, y0. That's just the starting. A lot of you have taken physics. Do you know like v sub 0, like initial velocity, like a little zero on that? Anyway, yes. They're going to give you a starting place and use an increment of h. I don't know why they use h, that's just the letter that they use. It's also called a step size, but again, you'll be given that in the problem as well. It'll say use a step size, or it'll actually just say h equals however much you're going to count by. So the way that you get the x values is like you start at x0. To get the next one, to get x1, you take where you started and you add h. That's easy. Like if h is a half, you just keep adding a half. So that's not bad, all right? To get the next y value, you take where you started plus that step size times the derivative at the previous point. It's like you use where you're at to get to the next one, and then you use that value to get to the next one, and then you use that value to get to the next one. The unfortunate thing about this is if you mess up one of them, then it messes up the next one. Do you get what I'm saying? Because it's like you rely on the previous answer to get where you're going. So just be really careful. We're just going to try a few of these. Okay, so here's what you would be given. You would be given dy dx. And let me just show you real quick, like why that's not separable. Like you can't actually solve the differential equation because you can't separate the variables. You could try to get y to the other side, but how would you do that? Yeah, add y. So like y plus dy dx. Like, do you see what I'm saying? Like why it's not going to work? This is called non-separable. So you can't actually get the answer. That's why we're going to approximate it. So you would be given that, you would be given your starting values. So we're going to start at 0, 1. And then you would be given an h value and also told what you're supposed to find. So we're going to approximate f of 0.3 with h equaling 0.1. The decimals are going to get messy, but the actual process isn't that bad. So you just kind of got to stick with me. So make a table. We're going to make an XY table. And we're going to start at the starting point, the first one that they gave us, which is 0, 1. So we're going to start at 0, 1. Now the x's are really easy to get. You just keep on adding h. It's the y's that are a bit of a fight that you have to get to. But our step size is 0.1. So we're just going to keep adding 0.1. So 0 plus 0.1 would be 0.1. And then what would the next one be? Yeah, 0.2 and then 0.3. Now I'm going to stop there. Why do I get to stop that? Like, how do you know when to stop? That's the one you're looking for, right? So stop. Now they don't usually have you go very far. All right, this is going to be enough. You'll see when we try to get the y values. Can you imagine going out like 10 of these? It would be like complete mess. You're already like, have you seen this method before? This isn't an A-B topic. Okay. So this is y0. To get y1, you're going to take where you started, which in this case is 1, plus the step size, that h value, which is 0.1, times the derivative at this previous point. dy dx is your derivative. So we're going to plug in 0 for x, 1 for y to our derivative. What would that give you if you plug these in? Good. 0 minus 1, that would give you -1. And then you work that out, and that's what goes right here. So let's see, this would be 1 plus, or actually it would be minus 0.1. And so that would be 0.9. So 0.9 goes right there. And then we're going to use that to get the next value. So to get y2, we're going to take 0.9, the one that we just had, plus that step size, the h value, 0.1, times the derivative at the previous point. So I usually just use my fingers to cover this up. We're going to find the derivative at this point, except this thing closed. There we go. So we're going to do the derivative at this point. Do you see why it keeps getting messier and messier the further you go? Because you're going to deal with all these decimals. So you're going to plug in 0.1 for x and 0.9 for y. I'm going to just go ahead and write it out. It would be 0.1 minus 0.9. And then we're going to work all that out. I know, it's super important. And whatever we get, that's what goes in the next box in the table. So this would be 0.9 plus 0.1 times, and then what is this going to give us? -0.8. So this will be 0.9 minus, because when we multiply these, it'll be -0.08. And here's where I tend to think about money. Like, everyone understands money, right? This would be 90 cents minus 8 cents. If you think of it that way, sometimes that helps. 90 cents minus 8 cents would be 82 cents. So 0.82 is what goes right there. 0.1 times 0.8 would be, oh yeah, that's a good way of thinking it, 10%. So 0.08, except it was negative. Yeah. And you're like, hallelujah, we only have to do one more. If you look these up on the internet, sometimes they do them out to like a table with like 10 values in it. It's like, oh my goodness, we're not going to do more than like this much, right? So y3, you're going to take where you just were, which is this 0.82, plus the step size, which is that 0.1, and then times the derivative at the previous point. So again, I usually just use my fingers to cover up the rest of the table. We're going to do the derivative at this point right here. So if you plug 0.2 in for x, 0.82 in for y. So it's 0.2 minus 0.82. We got to fight our way through this, but once we get this, it's our answer. And actually, if it was free response, you could stop here, right? And please do, okay, if it's free response. Let's pretend we had to keep going though, just for the sake of getting through this here. It would be 0.82 plus 0.1 times, all right, let's see. Think of money. This would be 20 cents minus 82 cents. That will be negative 62 cents. Think of money when you have the decimals like that. So this would be 0.82 minus 0.062. I'm going to just tell you what that is. 0.0758. or I'm sorry, 0.758. No, if you had to work it out by hand, you would have to actually stack them one on top of the other and then subtract it. Like, do you remember how to subtract and borrow from the number next to you? Like, yeah, you're rolling your eyes from back in like second grade or whatever. Actually, my son's doing that now and he's in fourth grade. He did that last year though, third grade. Learn how to subtract. All right, let's try another one. Do you guys see what I'm saying though? The process isn't hard, but sometimes yeah, like sometimes the arithmetic, it's not even algebra, it's arithmetic. Sometimes the arithmetic just gets like really, really messy. But that's why we don't make the charts go out very far. So you're given dy dx, you'll be given that, you'll be given a starting point, in this case 0, 3. We're going to approximate, this is your instructions, approximate f of 2, and your step size is a half. And usually that step size number is kind of a nice number. Like this one was a 10th, this one's a half. Like it's not usually 0.7, do you know what I'm saying? Like it's usually something fairly reasonable. All right, so make yourself an XY table. We're starting at 0, 3. That's the beginning point that they gave us, like the initial point. The X's are easy to fill in. You're just going to keep on adding a half. So we would have a half and then what? 1 and then 1.5. I'm going to go with fractions and then 2. We get to stop there because that's the one that we're being asked for. So again, you're not going to have to go very far. All right. Y'all buckled in? Here we go. Y1 equals, where are we going to start? 3 plus, here, go ahead and put the phone away. Plus what? H, which is a half. And then times the derivative at this point, which you would plug in 0 for X, 3 for Y. So 0 minus 6. So good, -6. So that is going to be 3 minus 3, which will give us 0. So actually that turned out not so bad. All right, let's do the second one. Where is that one going to start? 0, the one that we just got, plus a half, good. Times, and I usually cover up the rest of the chart so you can focus just on this. We're going to plug in 1/2 for X and 0 for Y. So 3 halves, good. I'm going to go with fractions on this one because they're halves and then those will turn into fourths. So it won't be too bad. So this will be 3/4. This one isn't too yucky yet. I might regret saying that though. We'll see how this goes. All right, where's this one going to start? 3/4, the one that you just had, plus a half times. All right, now cover up the rest of the chart so you don't confuse yourself because I know it's like number salad here. Yeah, you're plugging in 1 for X, so 3 minus, I'm going to write it out. If you plug in 3/4 here, 3 times 2 is 6, so 6/4, which would be 3 halves. Do some of it in your head, but at a certain point, you can't hold that many numbers in there. So just go ahead and write it down. All right, so 3/4 plus a half times, all right, 3 minus 3 halves. 3 minus 1.5 would be 1.5, right? So that would just be 3 halves. So this is 3/4 plus 3/4, which would be 6/4, which is 3 halves. One more, you can do it. This is really just more about perseverance than anything. All right, where's that one gonna start? 3 halves, yeah, the one that you just had, plus 1/2 times the derivative at the previous point. You're plugging in 3 halves for both of them. 3 halves times 3, that would be 9 halves minus, the 2's would cancel there and you would just get 3, but actually I will write that as 6 halves because then we have a common denominator there. So this will be 3 halves plus 1/2 times 3 halves So that is 3/2 plus 3/4, which will be 9/4. And that's your answer. Did I make that clear enough? Like this is your answer? Like when you get there, like this one, like that's your answer. Okay, I want to make sure you understand what the answer is. All right, let me give you guys one to try. You can work together with each other here. And then I have a fourth one if we have time for it, but I would like to get to it. We have some time, so as long as you guys are diligent, we'll get through it. I would just flip the paper over. Do you guys see why this is better without lines? Well, is my opinion. You can agree or disagree. And that does say g of x. This one's gonna be a little bit different. Yep, dy dx, and yeah, I know my handwriting is awful, I'm sorry. Yep, dy dx equals 2y plus g of x, and then they give you the values of g of x in a table. Oh, you're so fast. Sometimes I see you just sitting there and I'm like, is he doing anything? You're just done it already. Just finished. All right, we're gonna approximate. I thought I wrote fast, but apparently not. We're gonna approximate f of 1 step size of a fourth. And again, that step size is usually a sort of nice number, like a half or a fourth, or like the other one we did was 0.1. It's not usually like something real awful. Yeah, like 37/5 or something, you know what I mean? Like it's not like that. Because the rest of it is bothersome enough, okay? All right, so make your table. Let's see how far we have to go. Where are we starting? What's our starting point? Get 0, -2. And we're counting by a fourth for the x's. So it'll be a fourth here. You guys tell me when to stop. A fourth, a half, 3/4, 1, stop. Okay. You want to know where to stop because it's like you do not want to go further than you would have to. Do you remember when we did the chart problems with derivatives and you would just like write out the product rule and then get all the numbers from the chart? This one's kind of like that. Anytime you have a chart, you want to be like, yes, like all the numbers I need are right there. So this one's actually going to be less difficult with the arithmetic, if that makes sense, because we're just going to use these numbers for a lot of it. All right, so here we go. Y1 equals, where are we starting? -2, good, plus 1/4 times the derivative at this point. So when you plug in, it's 2 times y. So 2 times -2, that would be -4 plus g of x. Now x is 0, so look at your chart. What's g of 0 is 8. Good. So this will be -2 plus a fourth times 4. A fourth of 4 would just be 1, so -1. All right, next one. Crud, I'm going to speed this up to make sure I finish. It'll be -1 plus a fourth, and then you're going to plug this in for the derivative. 2 times y would be -2 plus g of x. X is a fourth, so getting that from the table be 14. So -1 plus a fourth times 12. A fourth times 12 would be 3, -1 is 2. I promise I can finish this. I have 3 minutes. All right, next one. You've got 2 plus a fourth times, all right, plugging in the 1/2 and the 2. 2 times 2 would be 4. Plus, if you get 1/2 from the chart, that's going to be 0. So once more, this would just be 1 plus 2 is 3. And then the last one, 3 plus a fourth times the derivative at that point. Plug in 3 for y, that'll give you 6. 3/4 from the chart over here is -4. So that's 3 plus a fourth times 2. All right, a fourth times 2 be 1/2, so 3 and 1/2. So 3.5 or 7/2. This is your answer. Again, if it was free response, please stop there.